the concept that you're learning. So basically what it's showing is here is the ratio. It's y over x. And then they're telling you, okay, here's what you put in this box right here. Wherever you see a y, you're going to put a 4. And this is the y on top. And wherever you see an x, you're going to put an 8. And then you have to simplify it. So what is 4/8 simplified? You would reduce it down to 1/2. Does that make sense to you?
Oh, so you put the 8 on the bottom and the 4 on top. So then you just simplify the answer.
Yep. And then on this line, they're saying x is 6 and y is 3. So then wherever you see the y, you're going to put a 3. And the x is a 6, and then you simplify. And then this one is a fraction, but that's okay. Fraction's a number. So you just put 1/4 on top, and then it's a fraction. That's the numerator, and then 1/2 on the bottom. And then you simplify it. So 1/4 divided by 1/2. An easy way to do it is to do your calculator. You do 1 divided by 4 equals 0.25. Divided by we know 1/2 is 0.5, right? 0.50. So then you're just going to do 0.25 divided by 0.5 equals 0.5, and that's 1/2, right?
Yeah.
Okay. Then this one, you're going to do same thing. And then now they're telling you, here's the relationship. The ratio x over y for each row of the table is equivalent to 3. And so they're saying that when you plug these numbers in, they picked the numbers, it just happens to be 3/1. But you would still do the same thing. You'd plug it in, and then when you simplified it, 9/3 it equals 3/1. 36/12 equal 3/1. This would equal, so it just happens, they're just pointing out that everything they gave you happened to come out to be a 3. Now, if it happens to be the same number, then they're saying, hey, this table shows a proportional relationship between x and y, which means this number's the same, this number's the same, this number's the same. For this one, are they all the same? So when you simplify 4/8, it's 1/2. When you simplify 3/6, it's 1/2. When you simplify this, all of them are 1/2. So is it a proportional relationship? Yes, because they all move in the same way, 1/2. Does that make sense to you?
Yeah.
Okay. For this one is 1/2. When you plug this in, this one's 3/7. When you plug this in, this is 1/3. When you plug this one in, it's 1/5. It says the ratio y over x for the rows of the table are not equivalent. Therefore, the table does not show a proportional relationship. So when you figure it out, all of these numbers are the same. It shows a proportional relationship. When they do not, it is not a proportional relationship. Does that make a little more sense? Kind of?
Yeah.
Okay. Next. It's a little tricky, but it'll start to make sense. The good news is it's either going to come out to be the same number or it's going to come out to be the different number, and that's how you'll know. You just plug in, they tell you what it is that you're supposed to be plugging in, and they'll tell you the numbers, and then you figure it out by solving it. So the diagram shows a series of squares drawn on graph paper. The side length and perimeter of each square is labeled. Use the diagram to complete the table. Draw the next few squares as needed. write all the ratio in simplest form. So they're basically telling you that this side right here, I don't know, can you see that? This side right here, the length is 1 and the perimeter is 4. So now you take the perimeter, you put it on top because they're telling you the ratio equals perimeter over side length. So when you look at that and you plug in your numbers, you would put in a perimeter of 4 over 1. So that's the ratio. Does that make sense to you?
But on the other one, like to the right of it, it has 2 fractions.
It does. Okay, so let's take that one. So for that one, they're saying the side is 2, which is why it's here, because they said that's the side length. And they want you to figure out the perimeter is 8. And we know that because this says perimeter and they filled in 8 for you. So you're going to fill in 8 right here because they actually told you that was the perimeter because they put it as the numerator. And now what they did, the reason why there's 2 fractions is they simplified it. So it was 8 halves and they simplified it to 4 over 1.
But all of my math teacher for school, he said that those fractions are, you can't do them because they're the little numbers on the bottom and the big numbers on the top.
Yeah, so this is called an improper fraction. And what that means is that the numerator is bigger and the denominator is smaller. And so when that happens, smaller, all that you have to do, it's super easy. You take the denominator and you put it right here, and you put the numerator right here. And what does it turn out to be? 4. Another way you can do it is this. 2 goes into 4, 8, how many times? 4. So it's the same thing, you just don't have to do the work. You can just say, how many times does 2 go into 8? And remember, you might have to watch this a couple times to have it make sense, which is totally, completely fine. Okay, for the next box, all they gave us was the length, and that's not helpful to figure it out. Unless, what, honey?
I have a question.
Yeah.
So when that happens, the improper fraction, do you fix it or do you just leave it?
You always fix it.
But how come the people that did the math didn't fix it?
They did.
What?
4 over 1. 4 over 1 is 4.
Oh, so you can't even fix it.
Yeah, it's already fixed. 4 over 1 and 4 is the same. It's the same exact thing. Every number, like suppose you said, I am 50 years old. It's really 50 over 1. But we don't say 50 over 1.
You just say 50.
Exactly. But that's what a whole number is. That's just, so this is, it's not an improper fraction anymore because it's over 1. Anything else would be an improper fraction, but not over 1. Yeah. Good question. So this one, it's not that helpful because they're only giving us the length, right? So we can put the denominator in, but we have no numerator and we have no perimeter. So what's good is if we look over here, there we go. It told us what the perimeter is. So if it's not in the table and they don't give it to you, you just look over here and they say, for this one, if the side is 3, the perimeter is 12. So then if I was doing this one, I would put in 12 because that's what my perimeter is. And now I can do 12 over 3 because remember it's perimeter over side length. And then I know I just go 3 goes into 12 how many times? 4 times. You don't have to totally 100% understand this. You just have to watch it a couple times, and then when your teacher teaches it to you and when you're on chapter 2, then you're going to start to understand it. So they showed you all the solutions down here. And then it's saying each ratio is equivalent to 4 over 1. So when you figure all of these out, this one's 4, this one's 4, this one's 4, this one's 4. And we know that all the ratios are equivalent. So it's showing a relationship between the side length and the perimeter. And then remember we learned if all the numbers are the same, then it is proportional. Okay, next one is, I think we just did the first one. Okay, the next one is a table can be used to show proportional relationships between two quantities. In the first row, the ratio of x over y is 2 over 1. So same thing, we're just going to plug in 2 over 1. In the second row, the ratio is 4 over 2. The third row is 5 over 3. Why do they say 6? I see that as a 5. Is that not the number 5? Doesn't that look like a 5 to you? Oh, it's a 6. Looks like a 5. And then fourth row is 8 over 4. So here's your 8, here's your 4. Now when we solve all of these, we see that it's 2 over 1, 2 over 1, 2 over 1, and 2 over 1. So is it proportional? It is, because each of them, when it's solved, will come out to be a 2.
So that's when you... So if you put these two together on the chart, and then you simplify them, they're all going to be the same, so that's how you know they're proportional?
Yeah, and if when you figure them out they're not the same, then they're not proportional. They're not going to always be proportional.
What? You just say it's not proportional?
Exactly. Yep. So our next example, when you solve, it's 2... 4, 6, and 8. So it is not proportional in the same way, but there is a pattern to it. So it does show a proportional relationship. And how I will know that is when I go from this tier to this tier and this tier to this tier and this tier to this tier, they're all going up by 2. So it does show a relationship. So there's 2 ways that a relationship can be shown. A relationship is there if the number is the same, or if there is a pattern that repeats each, it's not a column, it's a row. So because this is going up in the same exact way, it is twice the corresponding number, which means it's going up by 2. Times 2, times 2. Not times 2, but this is going up. 2 times 1 is 2. 2 times 2 is 4. 2 times 3. This is going up proportionately. So there is a pattern there.
Okay. So what if there's like one that's like goes 2 to 3? I mean, like, no, I mean 1 to 2, then to like 4.
Then it's not a pattern.
Okay.
So suppose it went 1, 2, 4, and 5. It's missing 3. If it went 1, 2, 3, 4, yes. But because there's a problem with the pattern here, it's not proportional.
So just one is not the right.
Yep, exactly. They all have to work or it doesn't matter. Okay, so, you know, this is chapter 2. You still are on chapter 1. So I think you're going to be fine. And then, so we just did, I think we did all of them now.